Close your eyes and imagine yourself standing at the edge of the world, where the land meets the endless expanse of blue. Feel the soft sand beneath your feet, still warm from the day's sun, but cooling now as evening approaches. The gentle breeze carries the scent of salt and minerals, ancient and familiar, as if your body remembers this place from long before you were born. Listen to the waves, that eternal rhythm rolling in and retreating, as they have done for billions of years. Each wave is a lullaby, each crest and fall a breath, inviting you to synchronize your own breathing with the sea's patient tempo. Tonight, we will journey together through the mysteries and marvels of the sea, discovering facts so soothing, so wonderfully calming, that you'll drift effortlessly into the deepest, most restful sleep. Let the sea carry you away. The sea's ancient origins, a 4-billion-year lullaby. The story of the sea begins in fire and chaos, yet from that tumult emerged the most peaceful substance on Earth. Imagine our planet as it was 4.5 billion years ago, a molten sphere of rock spinning through the darkness of space. The Earth was unrecognizable then, a world without oceans, without the soothing blue that now defines our home from the vantage point of space. The early Earth was a place of extremes, where temperatures soared beyond the boiling point of water, where the surface churned with liquid rock, and where any hint of the tranquil seas we know today seemed impossible. Yet deep within this hostile world, something precious was waiting. Trapped within the minerals and rocks that formed our planet were molecules of hydrogen and oxygen, the building blocks of water. These elements had been part of the cosmic dust and meteorites that gradually accumulated to form Earth, gifts from the ancient nebula that birthed our solar system. Scientists have discovered that carbonaceous chondrites, some of the oldest meteorites in our solar system, contain isotope levels remarkably similar to our ocean water, suggesting that these ancient space rocks delivered much of Earth's water during the planet's formation over 4 billion years ago. As the Earth slowly began to cool, a remarkable transformation occurred. The planet's interior remained searingly hot, but the surface started to solidify, forming the first thin crust. Within the depths of the Earth, intense heat and pressure caused volcanic activity on a scale we can barely imagine today. These volcanoes weren't just releasing lava, they were exhaling the planet's first atmosphere. Through a process called outgassing, water vapor trapped in the molten rocks was released into the atmosphere as the magma rose and the pressure decreased. Along with water vapor came carbon dioxide, sulfur dioxide, nitrogen, and other gases, the ingredients for Earth's early atmosphere. For countless millennia, the sky above our young planet was thick with water vapor, yet the surface remained too hot for liquid water to form. The Earth had to be patient, cooling degree by degree, century by century, millennium by millennium. Scientists estimate that the surface temperature needed to drop below the boiling point of water at the atmospheric pressure that existed then. This cooling was gradual, almost imperceptibly slow, yet it was inexorable. Then, approximately 4 billion years ago, something magical happened. The Earth's surface had cooled enough that when water vapor in the atmosphere condensed, it could fall as rain without immediately evaporating. Picture that moment. The first raindrops in the history of our planet, falling through the primordial atmosphere onto the still warm rocks below. Some of that water would have hissed and steamed upon contact, but not all of it. As the cooling continued, more and more rain fell, and instead of evaporating, It began to pool in the low places, the depressions and valleys of the early Earth's surface. This was not a brief shower but a deluge that might have lasted for thousands, perhaps millions of years. Rain fell continuously from the heavy, vapor-laden atmosphere, and slowly, gradually, beautifully, the first seas began to form. Water accumulated in the basins created by the tectonic movements and volcanic activity that shaped the young Earth's crust. These first seas were not calm. They were turbulent, hot, and probably quite acidic from all the carbon dioxide dissolved in them. But they were seas nonetheless, permanent bodies of liquid water, the first in Earth's history. The water cycle had begun. Water evaporated from these early seas, rose as vapor into the atmosphere, condensed, and fell again as rain. This cycle, which continues to this day, has been running for 4 billion years, a rhythm as eternal as the tides themselves. Think of it. The water in today's oceans has been cycling through this same process since before life existed on Earth, before continents as we know them, before anything we would recognize as familiar. The composition of seawater was established early and has remained remarkably stable. Most of the salts and dissolved elements in the ocean were probably outgassed along with the water vapor, which means the ocean has likely always been approximately as salty as it is now. While rivers carry dissolved minerals from weathered rocks into the sea, the ocean maintains a steady state. The rate of input balances the rate of removal through various processes like incorporation into living organisms and sediments, keeping the ocean's chemistry surprisingly constant over billions of years. Understanding that the water in our seas is ancient, that it has existed for nearly the entire history of our planet, brings a profound sense of continuity and peace. The waves lapping at shorelines today are composed of molecules that have witnessed the entire story of life on Earth, from the first simple cells to the complexity of modern ecosystems. When you float in the sea, you are cradled by 4 billion years of history, supported by waters that have remained fundamentally unchanged through all the transformations Earth has undergone. This deep time perspective, this connection to something so enduring, so much larger than our individual lives, has a way of putting our worries into perspective, of helping us understand that just as the sea has persisted through all of Earth's changes, we too can weather the storms of our own lives. The sea is patient. The sea endures. And tonight, as you drift towards sleep, let yourself be held by that ancient patience, that eternal endurance, the soothing science of ocean sounds. Why waves calm us. There is something profoundly hypnotic about the sound of waves. Whether you're standing on a beach listening to the surf crash against the shore, or drifting off to sleep to a recording of ocean sounds, the effect is unmistakable. Your breathing slows, your shoulders drop, your mind quiets. This is not merely poetic fancy. It is biology, neuroscience, and physics working in concert to create one of nature's most effective relaxation tools. The sound of waves is what scientists call broadband sound, similar to white noise, but more complex and varied. Unlike the jarring, unpredictable noises of urban environments, the sounds of the sea follow rhythmic, repetitive patterns that our brains find soothing. Each wave builds, crests, crashes, and retreats, creating a sonic pattern that repeats with comforting regularity. These slow, whooshing noises are the sounds of non-threats. When our brains process these sounds, they interpret them as signals of safety. It's as if the ocean is continuously whispering to our nervous system, "Don't worry, don't worry, don't worry." Research has shown that listening to ocean sounds can actually change our brain waves. When we hear the rhythmic patterns of waves, our brain waves begin to slow down, shifting from the beta waves associated with active thinking and stress to alpha waves, which occur at frequencies between 8 and 14 Hz. Alpha waves are associated with relaxed, meditative states, the mental territory between waking and sleeping, where creativity flourishes and anxiety diminishes. Clinical psychologist Richard Schuster has found that staring at the ocean actually changes our brain waves frequency and puts us into a mild meditative state. The auditory component works in much the same way. The calming effect goes even deeper. Listening to ocean sounds has been shown to activate the parasympathetic nervous system, the part of our nervous system responsible for rest, digestion, and recovery. When the parasympathetic system is activated, our heart rate slows, our blood pressure decreases, and our body releases less of the stress hormone cortisol. Studies have found that underwater sounds can decrease cortisol levels by up to 37% after just 15 minutes of exposure, which is significantly more effective than other nature sounds like forests or general white noise. This powerful response may have evolutionary roots. Throughout human history, the sound of water has signaled the presence of this vital resource. Our ancestors would have associated the sound of streams, rivers, and ocean waves with survival. Water meant life. Even today, our brains are hardwired to respond positively to water sounds, triggering a sense of safety and well-being that originates deep in our evolutionary past. The ocean provides what researchers call acoustic camouflage. This is a passive sound that drowns out many other noises and distractions, creating a sonic cocoon that helps clear our minds of anxieties and intrusive thoughts. In our modern world, we're constantly bombarded by sudden, unpredictable sounds. Car horns, sirens, phones buzzing, the complex cacophony of urban life. Our brains have to process each of these sounds, determining whether they represent threats or demands for our attention. This constant auditory vigilance is exhausting and stressful. The ocean offers an alternative. Its sounds are consistent, predictable, and all-encompassing, providing an audio mask that covers over the jarring noises of daily life. When researchers study people listening to ocean sounds, they observe fascinating changes. The sounds help synchronize our breathing and heart rate with the rhythmic patterns of the waves. This creates what's known as a biofeedback loop. As we relax, our breathing and heart rate slow down, which in turn amplifies the peaceful feeling, making us relax even more. It's a gentle spiral into deeper and deeper calm. The frequency range of ocean sounds, typically between 10 and 500 Hz, aligns beautifully with the brain's natural relaxation frequencies. This isn't a coincidence. It's the result of millions of years of evolution, of human brains developing in environments where water sounds were among the most consistent and important acoustic features. Marine biologist Wallace J. Nichols has extensively studied this phenomenon, proposing that our brains evolved to respond positively to water because it was essential for survival. Today, even though most of us have ready access to water, our brains still associate water, especially natural bodies of water like the ocean, with well-being, triggering neurological responses that promote relaxation and happiness. The color blue itself, so strongly associated with the ocean, has been shown to have calming effects. Studies indicate that blue environments can lower heart rate and blood pressure. Hospital rooms painted blue have been found to reduce patient stress. The endless blue of sea and sky at the beach creates a visual environment that's inherently soothing to our nervous systems, complementing all the other benefits the ocean provides. There's also something to be said for what the ocean doesn't have. A beach environment is typically free from the sensory overload of urban settings. No loud traffic, no flashing advertisements, no crowds rushing past. Even a popular beach has a different quality than a busy city street. The vastness of the ocean draws the eye outward rather than inward, and the natural sounds, waves, wind, seabirds, are generally softer and more rhythmic than mechanical sounds. This relative sensory simplicity allows the brain to rest and recover from the constant stimulation of modern life. For people who can't visit the ocean regularly, even smaller exposures to seawater can provide benefits. Swimming in ocean water pools, bathing with sea salt, or using seaweed-based skincare products can deliver some of the minerals and trace elements found in seawater. Recordings of ocean sounds or images of the sea, while not providing the same full-spectrum experience as being at the beach, can still trigger positive psychological responses and promote relaxation. The healing properties of the sea aren't magic, but they are real and multifaceted. They arise from the complex interplay of minerals, ions, sounds, sights, and the psychological effects of being in a natural environment that has deep evolutionary significance for our species. The ocean offers us a chance to immerse ourselves, literally and figuratively, in an environment that supports both physical and mental health. Tonight, imagine yourself floating in calm, warm seawater. Feel the salt water's buoyancy supporting you effortlessly, taking all the weight off your joints and muscles. The water is the perfect temperature, neither hot nor cold, just a comfortable embrace. You can taste the salt on your lips, feel the gentle rocking of the waves beneath you. As you float, you absorb the ocean's minerals through your skin, magnesium relaxing your muscles, trace elements supporting countless biochemical processes. You breathe in the sea air, rich with negative ions that lift your mood and calm your thoughts. The blue water stretches all around you, meeting the blue sky at a distant, hazy horizon. You're being healed by the sea. Not dramatically, not obviously, but gently, surely, in ways both physical and mental. Your body is receiving what it needs from this ancient medicine. Your mind is quieting, letting go of stress and worry, allowing the ocean's peace to seep in. Float now, supported completely, healing, resting, drifting towards sleep on the gentle swells. The gentle dance of sea creatures, symphony of the shallow waters. While we've spoken of whales and the creatures of the deep, there's a whole world of marine life that exists closer to the surface. In the sunlit waters where seagrass meadows wave gently in the current, where kelp forests create underwater landscapes of stunning beauty, and where creatures of all sizes engage in a slow, graceful dance that has continued for millions of years. Seagrass meadows are among the most peaceful and productive ecosystems in the ocean. These are not seaweeds but true flowering plants that have adapted to live entirely underwater. They have roots, leaves, and flowers, and they reproduce through pollination just like land plants, though their pollen drifts through water rather than air. Seagrass meadows grow in shallow coastal waters, their long, blade-like leaves swaying with the current in hypnotic patterns. These meadows provide crucial habitat for countless species. Young fish find shelter among the seagrass blades, protected from larger predators. Seahorses, Those most unusual and gentle of fish grip seagrass stems with their prehensile tails, swaying with the plants as they watch for tiny prey. Manatees, the gentle sea cows of tropical and subtropical waters, graze on seagrass, eating up to 1/10 of their body weight in vegetation each day. Watching a manatee feed is an exercise in patience and peace. These massive, slow-moving mammals drift languidly through seagrass meadows, using their flexible lips to grasp vegetation, chewing methodically, utterly unhurried. Sea turtles also depend on seagrass meadows. Green sea turtles, in particular, are primarily herbivorous as adults, grazing on seagrass and algae. These ancient creatures, which have existed in essentially their current form for over 100 million years, spend their days swimming slowly through shallow waters, occasionally surfacing to breathe, then diving back down to continue their patient grazing. There's a timeless quality to watching sea turtles. Their movements are so slow, so deliberate, that time seems to stretch and expand. They remind us that there's no need to hurry, that life can be lived at a gentler pace. Kelp forests, found in cooler coastal waters, create a different but equally mesmerizing environment. Giant kelp can grow up to 60 centimeters per day, making it one of the fastest-growing organisms on Earth. Yet from a human perspective, its growth is invisible. You could watch a kelp forest for hours and never see the plants visibly lengthening. The kelp creates an underwater forest, with long fronds rising from the seafloor toward the surface, creating a canopy that filters sunlight and provides habitat for a diverse community. Moving through a kelp forest is like walking through a terrestrial forest, except you're weightless, and the trees sway gracefully with every movement of the water. Fish weave between the kelp fronds. Sea otters wrap themselves in kelp to keep from drifting while they sleep on the surface, floating on their backs, often with pups resting on their chests. Sea urchins graze on the kelp's holdfast, the root-like structure that anchors the kelp to rocks. Sea stars crawl slowly along the seafloor, moving on hundreds of tiny tube feet, each step nearly imperceptible, but the cumulative motion carrying them across the bottom in their never-ending search for food. Jellyfish embody a different kind of peace, the peace of pure drifting. Most jellyfish are weak swimmers, capable only of pulsing their bells to move up or down in the water column. Horizontal movement is controlled by currents. Jellyfish go where the ocean takes them. There's something profoundly relaxing about watching jellyfish drift and pulse through the water, their translucent bodies catching and refracting light, their tentacles trailing behind them like ribbons. They have no brain, no central nervous system as we understand it, just a nerve net that coordinates their simple behaviors. They are creatures of pure sensation and response, living in the moment in the most literal sense possible. Some jellyfish, like the moon jelly with its 4 distinctive horseshoe-shaped gonads visible through its bell, are harmless to humans. Others, like the Portuguese man-of-war, which is technically not a jellyfish but a colonial organism made of many specialized individuals, have powerful stings. But even the dangerous species aren't aggressive. They sting in self-defense or to capture prey, not out of malice. They're simply living their lives, drifting through the ocean in the way their ancestors have for over 500 million years. Octopuses represent a different aspect of ocean life, intelligence and adaptability in an alien form. With 8 arms lined with suckers, 3 hearts, blue blood, and a brain that processes information in ways quite unlike our own. Octopuses are remarkable creatures. They can change color and texture almost instantaneously, blending into their surroundings or flashing displays of color when threatened or communicating. They can squeeze through openings barely larger than their beaks, the only hard part of their body. They've been observed using tools, solving puzzles, and even playing. Yet despite their intelligence and capabilities, octopuses move through the world with a fluid grace. They jet backward when alarmed, but most of the time, they crawl along the bottom using their arms, or drift through the water with gentle undulations of the webbing between their arms. Watching an octopus hunt is fascinating. It might sit perfectly still for long periods, waiting for prey to come within reach, then explode into action for a brief moment before settling back into stillness. Even their hunting speaks of patience and timing rather than constant activity. Manta rays glide through the ocean with wingspans that can exceed 7 meters. Yet despite their impressive size, they're gentle filter feeders, consuming tiny plankton as they swim. Watching a manta ray swim is like watching an underwater bird fly in slow motion. Their pectoral fins undulate in smooth, wave-like motions, propelling them effortlessly through the water. Groups of mantas sometimes swim in loose formations, their movements synchronized, creating a ballet of grace and power combined. Even the smallest creatures contribute to the ocean's peaceful symphony. Tiny copepods, shrimp-like crustaceans typically just a few millimeters long, are among the most abundant animals on Earth. They drift through the ocean in countless trillions, feeding on even smaller phytoplankton, and in turn being eaten by fish and other predators. Individually insignificant, collectively they form a crucial link in the ocean food web, converting the sun's energy captured by phytoplankton into animal protein that supports everything from sardines to whales. Coral reef fish, which we've touched on before, deserve special mention for their sheer diversity and the peaceful coexistence that many species achieve. On a healthy reef, dozens or even hundreds of fish species might live in close proximity. Parrotfish scrape algae from coral, their beak-like teeth audible as they bite and grind. Butterfly fish pairs mate for life and swim together, rarely separated. Cleaner wrasses set up cleaning stations where larger fish come to have parasites removed, and in these cleaning stations, predator and prey observe a temporary truce. Even fish that would normally eat the wrasse allow it to swim into their mouths and gills to clean them. This network of relationships, predation tempered by cleaning symbioses, competition balanced by niche specialization, constant activity that somehow coexists with an underlying stability, creates a system that has persisted for millions of years. Reefs change, species come and go, but the basic structure and function of the reef ecosystem endures. There's something hopeful in this resilience, this ability of life to organize itself into complex, beautiful patterns that persist despite disturbances. As you prepare for sleep, imagine yourself snorkeling in crystal clear, shallow water. Below you, a seagrass meadow waves gently in the current. A sea turtle swims past, moving its flippers in slow, powerful strokes, utterly unhurried. Jellyfish pulse through the water, their bells contracting and expanding in a rhythm that seems to echo your heartbeat. Small fish in rainbow colors dart among the seagrass, and in the distance, you can see the shadow of a manta ray gliding by, its wings moving in long, slow undulations. Everything moves at its own pace. Nothing rushes. The water supports you, holding you gently, rocking you with its subtle movements. You're a visitor in this underwater world, witnessing a dance that has continued since long before humans existed and will continue long after. Let the grace and patience of these creatures seep into your consciousness. Let their slow, purposeful movements calm your own mind. Feel yourself becoming part of their world, moving in rhythm with the water and the life it holds. Breathe slowly as the sea turtle breathes. Let each breath draw you deeper into relaxation, deeper towards sleep. You're safe here, peaceful here, in the gentle company of the ocean's creatures. The ancient seas, fossils, and time beyond measure. One of the most humbling aspects of the ocean is its age and the glimpses it provides into deep time. Time so vast that it challenges our ability to comprehend it. The ocean has been here in various forms for 4 billion years. Life has existed in the ocean for at least 3.5 billion years. And the fossils that the ocean has preserved tell us stories of worlds so different from our own that they seem like alien planets. Yet they're all chapters in Earth's history, all part of the long journey that led to the ocean we know today. The earliest evidence of life on Earth comes from the ocean. Stromatolites, layered structures created by communities of microorganisms, have been found in rocks 3.5 billion years old. Modern stromatolites still form in a few places, like Shark Bay in Australia, where they grow in shallow, very salty water. Looking at these living stromatolites is like looking back in time. They're built by bacteria in much the same way their ancient ancestors built the stromatolites we now find fossilized in ancient rocks. For billions of years, life remained simple, single-celled organisms, bacterial mats, nothing that we would recognize as animal or plant. Then, about 540 million years ago, something remarkable happened. In a relatively brief period of geological time, perhaps 10 to 25 million years, which sounds long but is brief in the context of Earth's history, a huge diversity of complex, multicellular animals appeared in the ocean. This event is called the Cambrian explosion, and it marks the beginning of most major animal groups we know today. Fossils from this period, preserved in exquisite detail in sites like the Burgess Shale in Canada, show us a world populated by creatures both familiar and utterly strange. There were trilobites, those iconic arthropods that would dominate ocean floors for the next 300 million years. There were early ancestors of mollusks, arthropods, and echinoderms. And there were creatures that don't fit neatly into any modern category. Hallucigenia with its spines and tentacles, Opabinia with its 5 eyes and vacuum hose-like proboscis, Anomalocaris, the top predator of its time, reaching up to 1 meter in length. These creatures lived, hunted, reproduced, and died in Cambrian seas more than 500 million years ago. Yet their fossils preserve them with stunning clarity. We can see the segments of their bodies, the spines they used for defense, the compound eyes they used to navigate their world. Holding a trilobite fossil, you're holding a creature that crawled across the seafloor when the continents were arranged in completely different patterns, when no life existed on land except perhaps bacterial mats at the water's edge, when the day was shorter and the moon appeared larger in the sky. The seas of the Paleozoic era, from 540 to 252 million years ago, gradually became populated with fish. The first fish lacked jaws and fed by filtering or sucking food from the sediment. Then jawed fish evolved, followed by fish with bony skeletons and fish with skeletons made of cartilage, the ancestors of modern sharks and rays. By the Devonian period, sometimes called the Age of Fishes, the oceans teemed with diverse fish species, from tiny, armor-plated creatures to massive predatory fish several meters long. During this time, some fish began venturing onto land, eventually giving rise to all land vertebrates: amphibians, reptiles, birds, and mammals. But the ocean continued to evolve its own lineages. Ammonites, nautilus relatives with coiled shells, became incredibly diverse and abundant. Marine reptiles, ichthyosaurs, plesiosaurs, mosasaurs, returned to the ocean from land ancestors and became top predators. Some of these marine reptiles rivaled modern whales in size. Then, 66 million years ago, the asteroid impact that killed the non-avian dinosaurs also devastated the oceans. The ammonites, which had survived for over 300 million years through multiple mass extinctions, finally went extinct. Many other marine groups were severely impacted. But the ocean recovered, as it always has. New species evolved to fill the empty ecological niches. Modern fish groups diversified. Whales evolved from land mammals and returned to the ocean. Seagrass meadows and kelp forests appeared and spread. The fossils of ancient marine life aren't just found in museums. Walk along many beaches, and you can find fossils yourself: shark teeth, ancient shells, imprints of long-extinct creatures. Each fossil is a connection to the ancient ocean, a reminder that the waves that lap at your feet are part of an ongoing story that has been unfolding for billions of years. There's something deeply peaceful about contemplating this vast sweep of time. Our individual worries, our daily stresses, even the major events of our lives, they're all so brief when set against the ocean's timescale. Entire civilizations have risen and fallen in the time it takes for some coral colonies to grow. The Roman Empire, which seemed so permanent to the Romans, lasted less than 1/5 of a second on a 24-hour clock where each hour represents 200 million years of Earth's history. This isn't meant to diminish the importance of human life or human concerns. Rather, it's meant to provide perspective. The ocean was here long before us. It will be here long after our species is gone, whatever form it might take then. The waves will keep rolling, the tides will keep rising and falling, the currents will keep flowing. There's something comforting about this continuity, this knowledge that we're part of something so much larger and longer lasting than ourselves. The ancient seas also remind us of resilience. Earth has been through dramatic changes, ice ages and warm periods, asteroid impacts and supervolcano eruptions, mass extinctions that killed the majority of species on Earth. Yet life has always recovered. The ocean has always persisted. It adapts, changes, but endures. This resilience is built into the very nature of life and water. Tonight, as you drift towards sleep, imagine yourself floating not just in the modern ocean but in the flow of time itself. Picture the waters around you as they were 1 billion years ago, empty of animals, inhabited only by bacteria and single-celled organisms. Watch as the Cambrian explosion fills the water with complex creatures, their strange forms darting and drifting through the ancient seas. See the fish appear and diversify. Watch marine reptiles prowl the depths. Witness the first whales entering the ocean and adapting to their new home. All of this history flows around you like currents, like the slow drift of continents, like the rise and fall of countless tides. You're floating on 4 billion years of ocean history, supported by water that has witnessed everything from the first living cells to the present moment. Let this deep time perspective wash away your immediate concerns. Let yourself be held by the knowledge that you're part of an ancient, ongoing story. The ocean's patience, developed over billions of years, can be your patience too. Rest now in the embrace of deep time, where individual moments dissolve into the eternal flow, where sleep is just another transition in the endless rhythm of existence. The poetry of ocean weather, where sea meets sky. The boundary between ocean and atmosphere is one of the most dynamic regions on Earth, where massive amounts of energy and water are constantly being exchanged. Understanding these interactions helps us appreciate both the power and the gentleness of the sea, and how intimately connected the ocean is to weather patterns that affect the entire planet. The ocean is Earth's primary heat storage and distribution system. Water has an exceptionally high heat capacity, meaning it can absorb or release large amounts of heat without changing temperature dramatically. This property makes the ocean a massive thermal buffer, moderating Earth's climate and creating the relatively stable temperatures that allow life to thrive. During the day, the ocean absorbs solar energy. The sun's rays penetrate the upper layers of water, warming them. Unlike land, which heats quickly but only at the surface, the ocean's warmth is distributed through mixing and currents, spreading heat through a much greater volume. At night, while land cools rapidly, the ocean releases its stored heat slowly, keeping coastal areas warmer than inland regions. This heat exchange between ocean and atmosphere drives many weather patterns. When sun-warmed ocean water evaporates, it takes heat energy with it into the atmosphere. This water vapor rises, and as it rises into cooler layers of atmosphere, it condenses back into tiny water droplets or ice crystals, forming clouds. When condensation occurs, the heat energy that was used to evaporate the water in the first place is released. This is latent heat, and it's a major driver of atmospheric circulation and weather systems. Clouds themselves are beautiful expressions of the ocean's moisture. Those fluffy cumulus clouds that drift across summer skies are made of water that recently evaporated from the ocean. The massive thunderheads that build on hot afternoons contain tremendous amounts of ocean water in vapor and droplet form. Even the thin, wispy cirrus clouds high in the atmosphere are ice crystals formed from water originally evaporated from the sea. Fog forms when moist air near the ocean surface cools to its dew point, the temperature at which the air becomes saturated and water vapor condenses into tiny droplets suspended in the air. Sea fog can be ethereal and beautiful, rolling across the water in thick blankets that obscure the horizon, making the world seem smaller and more intimate. Walking along a beach in fog is an experience of reduced sensory input. Visibility shrinks to just a few meters, colors are muted to grays and whites, sounds are dampened. It's an excellent environment for introspection and calm. The interface where warm ocean water meets cooler air, or where currents of different temperatures meet, can create stunning weather phenomena. The Grand Banks off Newfoundland, where the warm Gulf Stream meets the cold Labrador Current, is famous for its fog. This mixing of air masses with dramatically different temperatures creates conditions where fog forms frequently and can persist for long periods. Ships must navigate carefully, their foghorns sounding through the thick air, haunting sounds that speak of caution and careful progress through uncertain conditions. Hurricanes, typhoons, and cyclones, different names for the same phenomenon in different ocean basins, are perhaps the ocean's most powerful weather creation. These massive rotating storm systems form over warm tropical oceans where the water temperature exceeds about 26.5 degrees Celsius. The warm water evaporates, and as the moisture-laden air rises, it cools and releases its latent heat, which powers the storm. The rotation comes from the Coriolis effect, the apparent deflection of moving objects caused by Earth's rotation. While hurricanes can be destructive and dangerous, there's also something awe-inspiring about them. Seen from satellite images, they're remarkably beautiful, vast spirals of clouds rotating around a calm center, the eye of the storm. The eye is a region of descending air, clear skies, and relative calm, sometimes 30 to 60 kilometers across, surrounded by the eye wall where the strongest winds and heaviest rains occur. To be in the eye of a hurricane is to experience a strange contradiction. Calm conditions while knowing that tremendous violence surrounds you on all sides, and that the back half of the storm is approaching. Trade winds, those reliable winds that blow from east to west in the tropics, are driven by temperature differences between the equator and higher latitudes, and they're modified by the Coriolis effect and by the distribution of continents and oceans. These winds push surface waters westward in the tropics, creating currents and affecting the distribution of warm and cold water in the oceans. The trade winds were crucial for historical ocean voyages. Understanding their patterns allowed sailors to plan routes that took advantage of these reliable winds. The monsoons that affect large parts of Asia are another example of ocean-atmosphere interaction. During summer, land masses heat more quickly than the ocean, creating low pressure over land and high pressure over the ocean. Moist air flows from ocean to land, bringing heavy rains. In winter, the pattern reverses. The land cools quickly while the ocean retains heat, and winds blow from land to sea, bringing dry conditions to the coastal regions. El Niño and La Niña events demonstrate how changes in ocean temperature patterns can affect weather across vast areas. During El Niño, unusually warm water appears in the central and eastern tropical Pacific, disrupting normal weather patterns worldwide. Areas that usually receive heavy rain may experience drought, while typically dry regions may get flooding rains. La Niña brings the opposite pattern, cooler than normal water in the same region, with its own set of global weather impacts. These events occur irregularly, roughly every 2 to 7 years, and they show how interconnected Earth's climate system is. A temperature change in one part of the ocean can alter weather patterns halfway around the world. Watching ocean weather can be meditative. Clouds building over the sea in the afternoon, growing from small puffs to towering thunderheads. The way fog moves across the water, sometimes in distinct banks you can see approaching, other times forming all around you until you can barely see. The subtle color changes in the water as clouds pass over, creating patterns of light and shadow. The way the wind ruffles the water's surface, creating patterns that shift and flow. Even rain falling on the ocean has its own peaceful beauty. Each raindrop creates a tiny splash, and millions of raindrops create a constant patter, a white noise that many people find soothing. The rain dimples the ocean's surface, temporarily overwhelming the wave patterns, creating a different texture. Heavy rain can reduce visibility to almost nothing, creating a gray curtain between sea and sky where the two elements seem to merge. At sunset and sunrise, when the sun is low on the horizon, its light must pass through more of Earth's atmosphere to reach you. This filters out blue wavelengths and allows reds, oranges, and purples to dominate. Over the ocean, with its vast, unobstructed horizon, these colors can be spectacular. The underside of clouds catches the light and glows with warm colors. The sky can transition through a spectrum from deep blue overhead to violet, pink, orange, and red near the horizon. The ocean reflects these colors, creating a seamless transition between water and sky. These twilight moments over the ocean are times of transition, perfect for reflection and letting go. Day becomes night or night becomes day. The change is gradual, almost imperceptible moment to moment. Yet when you look away and then back, you notice how much has shifted. It's a reminder that change doesn't have to be sudden or jarring. It can be gentle, steady, natural. Tonight, imagine yourself on a boat, far from shore, as evening approaches. The sea is calm, just a gentle swell that rocks the boat slowly. Above you, clouds are breaking up after an afternoon shower, and the setting sun breaks through, painting the clouds in shades of gold and rose. The ocean picks up these colors, shimmering with reflected light. A light breeze carries the scent of salt and rain. You're at the intersection of sea and sky, water and air, day and night. All around you, the ocean breathes, evaporating water into the air, absorbing warmth from the sun, releasing it slowly as the day ends. You breathe with it, your lungs filling and emptying in rhythm with the swells, your body temperature moderated by the breeze off the water. You're part of this system, this exchange between ocean and atmosphere, between heat and cool, between water and vapor. Let yourself merge with these natural processes. Let the gentle rocking of the boat, the beautiful colors in the sky, the peaceful rhythm of waves and breath carry you into sleep. You're held by the ocean, sheltered by the sky, suspended between elements in perfect balance. Rest now, at peace with the sea and the weather it creates. If you enjoyed this relaxing journey through the science of the sea, please don't forget to like this video and subscribe to Deep Science Sleep for more calming educational content to help you drift off to sleep. Sweet dreams, and I'll see you in the next video. Wallace J. Nichols, author of Blue Mind, has extensively researched how our brains are hardwired to react positively to water. He writes, "We are beginning to learn that our brains are hardwired to react positively to water, and that being near it can calm and connect us, increase innovation and insight, and even heal what's broken. The benefits extend to sleep quality as well." Researchers have found that the repetitive nature of ocean wave sounds has a calming effect on the brain, with brainwaves synchronizing to the rhythmic pattern of the waves. This synchronization promotes a sense of tranquility and reduces anxiety. It also helps regulate breathing and heart rate, both of which are crucial for falling asleep and staying asleep through the night. The ocean sounds create a soothing background noise that masks disruptive environmental sounds, allowing people to enter and maintain peaceful slumber more easily. For many people, ocean sounds also evoke positive memories and associations. If you've ever had a relaxing vacation at the beach, or if childhood summers were spent by the shore, the sound of waves can transport you mentally back to those places of joy and relaxation. This mental time travel triggers feelings of comfort and happiness, creating an instant sense of well-being. The brain retrieves these cherished memories when it hears ocean sounds, flooding the mind with calming sensations and happy associations. There's even evidence that the color blue, which we so strongly associate with the ocean, contributes to the calming effect. Blue is widely recognized as a color that promotes feelings of peace and tranquility. Studies have shown that blue can lower heart rates and blood pressure, creating a physiological response that reinforces the calming effect of the ocean sounds. When we listen to ocean sounds and visualize the blue waters, we're engaging multiple senses in the relaxation process, amplifying the beneficial effects. The ocean gives our brains a much-needed break. Unlike the complex, information-dense environments most of us inhabit daily, the sight and sound of ocean water is relatively simple for the brain to process. This allows what researchers call effortless attention, a state where the brain can engage with its surroundings without strain or effort. This restful attention allows the brain to recover from the mental fatigue of focused work and goal-driven activity, restoring clarity and enhancing creativity and problem-solving abilities. Tonight, as you listen to the waves in your mind, imagine standing on a quiet beach at twilight. Feel the rhythm. Wave builds, wave crests, wave crashes and spreads across the sand. Wave retreats, pulling pebbles and sand with it in a gentle rattle. The pause. Then the next wave begins to build. Your breathing synchronizes with this pattern naturally, effortlessly. Breathe in as the wave builds. Hold gently at the crest. Exhale as it crashes and spreads. Pause in the quiet between waves. The ocean is breathing with you, and you are breathing with the ocean. Let this ancient rhythm carry you deeper into relaxation, deeper towards sleep. The gentle giants of the deep, whale songs and ocean communities. In the vast blue depths, there exists a world of sound we rarely witness but which speaks to something deep within us. The songs of whales. These magnificent creatures produce some of the most complex, hauntingly beautiful vocalizations in the animal kingdom, and understanding their gentle communications can deepen our sense of peace and connection to the sea. Humpback whales create what marine biologist Philip Clapham describes as probably the most complex song in the animal kingdom. These songs are not random sounds but structured compositions with phrases, themes, and patterns that can last for hours. A male humpback will sing continuously, repeating his song over and over, and remarkably, all the males in a particular region will sing approximately the same song in any given season. Even more fascinating, these songs change over time. New elements are added, old ones fade away, creating an evolving musical tradition that passes through whale populations like cultural knowledge. While the exact purpose of these songs remains somewhat mysterious, they appear to serve multiple functions. Initially, scientists believed they were purely for attracting mates, but evidence suggests they also play roles in establishing dominance among males, in spatial orientation during migration, and perhaps in the simple expression of being alive in the vast ocean. The songs carry for enormous distances through the water. Using underwater listening systems originally designed to track submarines, researchers have discovered that whale songs can travel for thousands of kilometers through the ocean, allowing these animals to communicate across distances that would take days or weeks to swim. The songs travel so far because of a unique feature of the ocean called the SOFAR channel, or sound fixing and ranging channel. This natural phenomenon occurs at depths between 600 and 1200 meters in temperate waters, where unique temperature and pressure conditions create a perfect pathway for sound waves to travel with minimal loss of energy. It's nature's own acoustic highway, and whales have evolved to take advantage of it. Scientists have documented cases where whale songs transmitted through the SOFAR channel have been detected up to 4,000 kilometers from their source. That's the distance from New York to Los Angeles. Blue whales, the largest animals ever to have lived on Earth, produce songs of staggering volume and profound depth. Their calls can reach 188 decibels, louder than a jet engine, yet they're pitched so low that humans can barely hear them. These songs consist of pulses, moans, and whoops that can last for 10 to 30 seconds each. Worldwide, blue whales sing about 13 distinct songs, with different populations in different ocean basins having their own unique vocalizations. In the Northeast Pacific, researchers have observed fascinating patterns. During summer feeding seasons, blue whales sing mainly at night, but when they begin their migration to breeding grounds, they switch to daytime singing, as if their song announces the start of their 4,000-mile journey. Bowhead whales, which spend their entire lives in Arctic waters, have revealed another astonishing dimension to whale music. For decades, scientists assumed that bowhead songs, like those of humpbacks, were relatively simple and repetitive. But when researchers deployed recording equipment that could remain in icy waters for months or years, capturing sounds even through the harsh Arctic winter, they discovered something remarkable. Bowhead whales sing intricate and highly variable songs, more like jazz musicians improvising than classical composers playing the same piece. Over 5 years of recordings, researchers documented no instances of a song being reused from one year to the next. Each season brought entirely new compositions. Some songs sound like screaming, others like creaking ice, and occasionally like police sirens. The variety is astonishing, and it suggests a level of creativity and cultural transmission that we're only beginning to understand. These marine mammals communicate not just through complex songs, but through a rich vocabulary of other sounds. Whale watchers have observed mother whales making cooing-like noises while lifting their young toward the surface in playful motions, sounds that seem designed to relax and comfort their calves. This is one of several distinct everyday noises whales are known to make beyond their elaborate songs. Toothed whales and dolphins produce unique high-pitched clicking sounds, which they use for echolocation to navigate and find food, and which also seem to function as individual identification signals, allowing them to announce who they are to other members of their pod. The ocean's gentle giants also communicate through body language. Whales breach, launching their massive bodies out of the water, and slap their tails against the surface. Scientists think humpback whales slap their tails to attract other individuals, and that this tail slapping might also communicate a desire to join or leave a group. They engage in spy hopping, where they surface vertically with their heads above water, seeming to survey their surroundings. These physical gestures, combined with their vocalizations, create a complex system of communication that helps maintain social bonds, coordinate group movements, and navigate the enormous expanses of ocean they call home. Perhaps most touching is the evidence of community and cooperation among marine mammals. While we often think of the ocean as a realm of fierce predation, it's also a place of remarkable gentleness and mutual support. Dolphins form tight-knit social groups, caring for injured members and working together to protect the young and vulnerable. Whales undertake migrations in coordinated groups, their songs and calls helping maintain cohesion, even when individuals are separated by considerable distances. There's a peaceful coexistence among many species, a ballet of life where each creature has its role, and where cooperation often proves more valuable than competition. The migrations themselves speak to a kind of patient determination that can inspire us. Gray whales, for instance, undertake one of the longest mammal migrations on Earth, traveling up to 20,000 kilometers round trip between their feeding grounds in the Arctic and their breeding lagoons in Baja California. They do this slowly, methodically, following routes their ancestors have followed for millennia. Humpback whales travel from polar feeding waters to tropical breeding grounds, a journey of thousands of miles. Throughout these migrations, they maintain acoustic contact with each other, their songs bridging the vast distances, keeping the community connected. Listening to recordings of whale songs, even at frequencies shifted so human ears can appreciate them, often evokes a profound sense of peace. There's something deeply moving about these massive, intelligent creatures singing in the darkness of the deep ocean. Their songs remind us that we share this planet with other beings who communicate, who have culture, who maintain social bonds and traditions. In a world that can feel dominated by human noise and activity, whale songs are a reminder of the vast, ancient world that exists beneath the waves, largely unchanged by our presence, following rhythms established over millions of years of evolution. Tonight, as you settle into sleep, imagine you're floating peacefully in warm, calm waters. Below you, far below in the blue depths, you can hear the faint song of a humpback whale, that low, mournful, beautiful sound that speaks of vast distances and patient journeys. The song is not for you, but you're privileged to hear it nonetheless. It rises from the depths like a lullaby, reminding you that you're part of something much larger than yourself, part of a living ocean where creatures of grace and wisdom have been singing their songs since long before humans walked the earth. Let their ancient music soothe you. Let it carry you gently down into the peaceful depths of sleep. Bioluminescence, the ocean's night lights. Imagine standing on a beach on a moonless night, and with each step you take in the shallow water, blue-green sparkles swirl around your feet. Touch the water and it glows. Watch a wave crash, and the foam shimmers with ethereal light. This is bioluminescence, one of the ocean's most magical phenomena, a gentle light show that has enchanted humans for millennia. Bioluminescence is the production of light by living organisms through chemical reactions inside their bodies. In the ocean, this ability is remarkably common. Researchers estimate that nearly 75% of marine animals have the ability to create their own light. In the darkness of the deep sea, between 200 and 1,000 meters below the surface, approximately 80% of the animals are bioluminescent. This makes bioluminescence one of the most common adaptations in the ocean, yet most of us rarely see it. The chemistry behind this living light is elegant in its simplicity. Bioluminescence involves a reaction between a molecule called luciferin and an enzyme called luciferase. When luciferin reacts with luciferase in the presence of oxygen, it produces light. The reaction is remarkably efficient, converting chemical energy directly into light with very little heat, unlike fire or incandescent bulbs, which waste much of their energy as heat. This cool light has evolved independently at least 40 times in different lineages of life, suggesting that it provides significant survival advantages. The colors of bioluminescence vary, though in the ocean, most bioluminescent light is blue-green. This isn't random. Blue-green light travels farther through water than other colors. Light at these wavelengths can penetrate the deep ocean where red and yellow lights would be quickly absorbed. Most marine organisms are also only sensitive to blue-green colors, their eyes having evolved to detect the wavelengths that actually reach them in their deep water habitats. Different creatures use their light-producing abilities in wonderfully varied ways. Some fish, like anglerfish, have a bioluminescent lure dangling in front of their mouths. In the pitch-black depths where they live, this glowing lure attracts smaller fish, which mistake the light for prey or perhaps a mate, only to be snapped up by the anglerfish's massive jaws. It's a patient form of hunting, requiring the anglerfish to simply hang motionless in the dark, its lure glowing invitingly, waiting for curiosity to bring a meal within reach. Other creatures use bioluminescence for defense. When threatened, many squid release clouds of bioluminescent fluid rather than ink. The glowing cloud confuses predators, who focus on the bright, drifting light while the squid makes its escape in the darkness. Some small fish have rows of light-producing organs called photophores along their bellies. When viewed from below, these photophores emit light that matches the faint glow of the surface water far above, making the fish nearly invisible to predators looking up for silhouetted prey, a defense mechanism called counterillumination. Perhaps the most familiar form of marine bioluminescence occurs at the ocean's surface, created by countless tiny organisms called dinoflagellates. These single-celled algae exist in concentrations so dense that during the day, they can make the ocean appear reddish-brown. But at night, when disturbed by movement, whether by waves, a swimming fish, or a person wading through the shallows, they flash blue-green light. A biological clock triggers the production of the chemicals responsible for their light as dusk approaches. Then, when mechanical stress disturbs them, they glow. Each individual dinoflagellate produces only a tiny flash of light, lasting just half a microsecond, 500 thousandths of a second. But because there can be millions of dinoflagellates in a small area of water, their collective flashing creates a visible glow. We don't perceive the individual flashes. Instead, we see a continuous shimmer, an ethereal glow that seems to emanate from the water itself. The effect is mesmerizing, especially when conditions are just right and entire beaches glow with each breaking wave, or when a boat's wake trails streaming ribbons of living light. Charles Darwin observed this phenomenon during his famous voyage on the Beagle, and he described it in his journal with wonder. While sailing in these latitudes on one very dark night, the sea presented a wonderful and most beautiful spectacle. There was a fresh breeze, and every part of the surface, which during the day is seen as foam, now glowed with a pale light. The vessel drove before her bows 2 billows of liquid phosphorus, and in her wake she was followed by a milky train. Some bioluminescent organisms bundle their luciferin with oxygen in what's called a photoprotein, creating a pre-packaged bioluminescence bomb that's ready to light up the moment a certain ion, typically calcium, becomes present. This gives the organism precise control over when they glow, allowing them to flash on and off rapidly for communication or to startle predators with sudden bursts of light in the darkness. Jellyfish are among the most beautifully bioluminescent creatures. Their translucent bodies can glow with an otherworldly light, pulsing gently as they drift through the dark water. Some jellies glow when disturbed, a defensive response to startle whatever has bumped into them. Others may use their light to attract prey or to communicate with members of their own species. Watching a bioluminescent jellyfish is like watching a living lantern, a creature made of light and water, moving with the currents in a slow, hypnotic dance. There are even larger displays of bioluminescence. Milky seas are rare but spectacular phenomena where huge areas of ocean, sometimes large enough to be visible from satellites in orbit, glow continuously with a uniform milky light. These events are thought to be caused by massive blooms of bioluminescent bacteria on the ocean's surface. Unlike the flash-on-contact bioluminescence of dinoflagellates, milky seas produce a steady glow that can last for hours or even days. Sailors who have witnessed milky seas describe the ocean transformed into a vast, glowing plain, the waves no longer visible as distinct features, but as part of one continuous luminous surface. It's an experience that seems more dreamlike than real. The purpose of bioluminescence varies. Besides hunting, defense, and camouflage, many creatures use their light to find mates. Flashes of light in the darkness can serve as signals, allowing males and females to find each other in the vast ocean. Some species have specific patterns of flashes, a sort of Morse code of light, that helps individuals of the same species recognize each other even in the crowded, dark waters of the deep sea, where many different types of bioluminescent creatures might be present. Scientists are still discovering new bioluminescent organisms and learning more about how and why they glow. The study of bioluminescence has led to important advances in medical research, as scientists have learned to use bioluminescent molecules as markers to track cellular processes and to study diseases. The discovery of green fluorescent protein in jellyfish even led to a Nobel Prize and has revolutionized molecular biology. For our purposes tonight, though, we can simply appreciate the gentle beauty of these living lights. There's something profoundly soothing about bioluminescence. Unlike the harsh, artificial lights that illuminate our modern world, bioluminescent light is soft, gentle, and perfectly adapted to its environment. It doesn't pollute the darkness, but rather enhances it, creating pockets and patterns of light that guide, attract, and communicate without overwhelming the natural rhythm of day and night. As you drift towards sleep, imagine yourself floating in warm, calm water on a dark night. All around you, the water sparkles and glows with each gentle movement you make. The light is cool and blue-green, peaceful and mysterious. Below you, in the depths, you can see the occasional flash of a jellyfish, the soft glow of fish swimming past, the constellations of photophores on creatures too deep to see clearly. You're surrounded by living light, by millions of tiny organisms and larger creatures, all contributing to an underwater galaxy. It's a light show created not for entertainment but for survival, for communication, for life itself. And yet, for you, in this moment, it's purely beautiful, purely peaceful. Let the gentle glow soothe your eyes, your mind, your whole being. Let it remind you that even in darkness, there is light, there is beauty, there is life continuing in its ancient patterns. Rest now, cradled by these living lights, and let sleep find you in this glowing ocean of dreams. The meditative world of coral reefs, patience built in stone. There are few ecosystems more vibrant, more complex, and more beautiful than coral reefs, and yet, paradoxically, few that teach us more about patience and the power of slow, steady growth. Coral reefs are sometimes called the rainforests of the sea, and this comparison is apt. They support tremendous biodiversity, providing habitat for roughly 1/4 of all marine life despite covering less than 1% of the ocean floor. But unlike rainforests, which can grow to maturity in decades or centuries, coral reefs are built over millennia, polyp by tiny polyp, in a process so gradual it defies our human sense of time. Let's begin with what corals actually are. Though they might look like rocks or plants, corals are animals, specifically simple animals called polyps. Each coral polyp is a small, soft-bodied creature, usually just a few millimeters in size, with a mouth surrounded by tentacles that it uses to catch tiny prey floating in the water. Individually, a coral polyp is fragile and vulnerable, but corals are colonial creatures, meaning thousands or even millions of polyps live together, connected, sharing resources and building communal structures. The structure that corals build, the hard, rock-like formation we think of when we picture a coral reef, is made of calcium carbonate, the same material found in limestone and chalk. Each polyp secretes calcium carbonate from its base, creating a tiny cup-shaped skeleton that protects it. Over time, as generation after generation of polyps live and die, these skeletons accumulate, building up the reef structure. Some massive coral formations are several meters tall and contain colonies that have been growing for hundreds or even thousands of years. This growth is extraordinarily slow. Massive corals, like brain corals or boulder corals, may grow only 3 to 20 millimeters per year. That's 0.3 to 2 centimeters. At this rate, a coral formation 1 meter tall could be anywhere from 50 to over 300 years old. Branching corals grow somewhat faster, up to 10 centimeters annually, but even they require decades to create substantial structures. When we look at a coral reef, we're looking at centuries or millennia of patient construction, each polyp adding its tiny contribution to a structure that will outlast it by generations. This slow growth is actually beautiful in its own way. It reminds us that not everything valuable can be rushed, that some of the most magnificent creations in nature require time, patience, and the steady accumulation of small efforts. Each coral polyp doesn't try to build the entire reef. It simply does its part, secreting its bit of calcium carbonate, feeding when food drifts by, reproducing when the time is right. Yet from these millions of small, individual actions emerges something grand and complex. Central to the success of reef-building corals is a partnership, a symbiotic relationship that has existed for over 210 million years. Living within the tissues of most reef-building corals are microscopic algae called zooxanthellae. These single-celled organisms are what give corals their beautiful colors. The coral tissue itself is actually transparent, so the color we see comes from the billions of algae living inside the polyps. The relationship between coral and zooxanthellae is mutually beneficial, which biologists call mutualistic symbiosis. The coral provides the algae with a protected environment, a place to live safe from being eaten or washed away. The coral cells also produce carbon dioxide and water, which the algae use for photosynthesis. In return, the algae use sunlight to create sugars and other organic compounds through photosynthesis, and they transfer up to 90% of what they produce to their coral hosts. These nutrients provide the coral with most of its energy, allowing the coral to grow and reproduce much more effectively than it could without its algal partners. This partnership also helps build the reef structure itself. Corals with zooxanthellae can deposit calcium carbonate up to 10 times faster than corals without these symbiotic algae. This is one reason why most reef-building corals are found in shallow, clear, sunlit waters. The algae need light for photosynthesis, so the corals must live where sunlight can penetrate, typically in the upper 60 meters of the ocean. The interdependence of coral and zooxanthellae is so complete that if the relationship breaks down, the coral suffers dramatically. When corals become stressed, often from water temperatures rising even just 1 degree Celsius above normal summer maximums, they expel their zooxanthellae. Without the algae, the coral turns white, a process called coral bleaching. The coral isn't dead when it's bleached, but it's starving, deprived of most of its nutrition. If conditions don't improve and the coral can't reestablish its relationship with zooxanthellae, it will eventually die. Yet even this challenging aspect of coral life teaches us something about balance and resilience. Corals have survived for hundreds of millions of years, through ice ages and warm periods, through changes in ocean chemistry and sea level. They've persisted because of their ability to adapt, to form partnerships, and to build structures that provide stability in an ever-changing environment. Different types of zooxanthellae thrive in different conditions, and some corals can swap their algal partners if conditions change, taking on types that are better suited to the new environment. It's a kind of flexibility within consistency, the ability to adjust while maintaining the essential structure of the partnership. Beyond the zooxanthellae, corals host diverse microbial communities. Bacteria living in and on corals contribute to nutrient cycling, with some species helping to fix nitrogen from the water or increasing the bioavailability of iron for the algal symbionts. Others produce compounds that protect against pathogens or help with calcium carbonate deposition. The coral structure itself becomes a habitat for countless other organisms: fish, invertebrates, algae, sponges, creating a complex community where everything is interconnected. Walking through a coral reef or swimming above one, as it were, since walking on reefs damages them, is like moving through an ancient, living cathedral. The coral formations rise like columns and arches, creating hiding places, overhangs, crevices, and caves. Small fish dart among the branches of staghorn corals. Larger fish cruise slowly along the reef face. Sea anemones wave their tentacles in the current. Snails, worms, and crustaceans live in the nooks and crannies. At night, the reef transforms as diurnal creatures seek shelter and nocturnal ones emerge. Coral polyps extend their tentacles fully, feeding on the zooplankton that rise from deeper waters under cover of darkness. The colors of a coral reef are astonishing. Beyond the greens, browns, and yellows from various types of zooxanthellae, corals also produce their own pigments, creating blues, purples, pinks, and reds. These colors serve multiple functions. Some pigments may protect the coral from excessive sunlight. Others may enhance the zooxanthellae's photosynthesis by scattering light deeper into the coral tissue. And still others may help defend against disease or advertise the coral's health to potential partners during reproduction. Reproduction in corals is itself a marvel of natural timing and coordination. Many coral species are broadcast spawners, meaning they release eggs and sperm into the water where fertilization occurs externally. What makes this remarkable is the synchronization. On certain nights, usually following a full moon and triggered by temperature, day length, and other environmental cues, entire reefs will spawn simultaneously. Millions of polyps release their gametes at the same time, creating an underwater snowstorm of pink and red bundles floating toward the surface. This mass spawning event happens only once or twice a year for most species, and it must be precisely timed. If an individual coral spawns too early or too late, its gametes won't encounter those from other corals, and reproduction fails. Scientists are still discovering exactly how corals coordinate these spawning events. Research suggests they have biological clocks sensitive to lunar cycles, water temperature, and seasonal changes in day length. The synchronization is so precise that on some reefs, different species spawn on different nights, creating a spawning calendar that extends over several nights, but where each species' peak occurs in a narrow window just a few hours long. After fertilization, coral larvae drift in the ocean currents, sometimes for days or weeks, before settling on a hard surface and beginning to build their own calcium carbonate skeletons. The survival rate is extremely low. Most larvae are eaten or fail to find suitable habitat, but those that succeed will potentially live for centuries, contributing their calcium carbonate to the growing reef and hosting their own zooxanthellae. There's something profoundly meditative about contemplating coral reefs. Their existence is a reminder that great things can be built slowly, that cooperation and symbiosis can create structures of surpassing beauty, that patience and persistence can produce results that last for thousands of years. In our fast-paced world, where we expect immediate results and rapid growth, the coral reef stands as a counterpoint, showing us that some of the most valuable and enduring creations cannot be rushed. Imagine yourself snorkeling above a coral reef on a calm, sunny day. The water is so clear you can see every detail of the corals below. The rounded dome of a brain coral, its surface covered with meandering valleys that trace patterns reminiscent of cerebral folds. The delicate branches of elkhorn coral, reaching upward toward the light. The vibrant purple of a soft coral swaying in the gentle current. Fish of every imaginable color glide past. Electric blue tangs, yellow butterfly fish with their distinctive black markings, striped angelfish, and schools of silver sardines that move as one, their bodies flashing in the sunlight as they turn in unison. The water is warm and buoyant, holding you effortlessly. You float above this underwater garden, breathing slowly through your snorkel, watching the peaceful dance of life that has been choreographed over millions of years. There's no hurry here, no deadline, no pressure. The reef has been here for centuries. It will likely be here for centuries more. Everything moves at its own pace. The slow waving of coral polyps' tentacles, the leisurely swimming of a sea turtle, the gradual drift of the current. Let this slowness, this patience, this ancient rhythm sink into your consciousness. Let it remind you that you too can move through life with grace and patience, that your own small, steady efforts can build something meaningful over time. Rest now in the knowledge that just as each coral polyp contributes to the reef without needing to see the whole structure, you too can trust that your efforts, your growth, your journey have meaning even when you can't see the full picture. Let the reef's timeless beauty soothe you into peaceful sleep. Ocean currents, the sea's gentle breath. If we think of the ocean as a living entity, then ocean currents are its circulatory system, its breath, the slow pulse that distributes warmth, nutrients, and life throughout the global seas. Understanding these currents reveals a world of gentle, persistent motion, of waters that travel the globe on journeys lasting hundreds or even thousands of years, connecting all the world's oceans in one vast, flowing system. Ocean currents are driven by several forces working together. The most familiar are surface currents, pushed along by winds that blow across the water's surface. The trade winds in the tropics, the westerlies in the mid-latitudes, and the polar easterlies all contribute to a predictable pattern of surface currents that have been used by sailors for centuries. The Gulf Stream, which carries warm water from the Gulf of Mexico up along the eastern coast of North America and across to northern Europe, is perhaps the most famous of these surface currents. At its peak, the Gulf Stream transports over 150 million cubic meters of water per second. That's more than 150 times the flow of all the world's rivers combined. But there's another type of current, deeper and slower, driven not by wind but by differences in water temperature and salinity. This is called thermohaline circulation, from thermo meaning heat and haline meaning salt. Cold water is denser than warm water, and salty water is denser than fresh water. When water becomes particularly cold and salty, it sinks, and this sinking drives a global pattern of deep ocean currents, sometimes called the ocean conveyor belt. The process begins in the far North Atlantic, in the seas around Greenland and Iceland. Here, warm, salty water carried north by the Gulf Stream encounters the frigid Arctic air. As the water cools, it becomes denser. Additionally, when ice forms in these polar regions, the salt doesn't get incorporated into the ice. It's left behind in the water, making the remaining liquid water even saltier and thus even denser. This cold, dense water sinks to the ocean floor and begins flowing southward as a deep current, creeping along the ocean bottom. This deep water current travels all the way down the Atlantic Ocean, around the southern tip of Africa, and into the Indian and Pacific Oceans. Eventually, thousands of years later, this water upwells, rises back to the surface, in various locations, particularly around Antarctica and in the Pacific. Once at the surface, it warms, becomes less dense, and begins the long journey back, closing the loop of the global conveyor belt. Scientists estimate that a complete circuit of the ocean conveyor belt takes approximately 1,000 to 2,000 years. This might seem impossibly slow, but it's this very slowness that makes thermohaline circulation so important for global climate. The movement of water from the tropics to the poles transfers enormous amounts of heat. The warmth carried by the Gulf Stream, for instance, is credited with making northwestern Europe significantly milder than other regions at the same latitude. Without the Gulf Stream's warmth, London would have a climate more similar to Labrador in Canada, despite being at similar latitudes. The ocean conveyor belt also distributes nutrients and oxygen throughout the world's oceans. When deep water upwells, it brings nutrients from the deep ocean back to the surface, fueling the growth of phytoplankton and supporting rich marine ecosystems. The oxygen dissolved in the water when it sinks in polar regions travels with that water, reaching even the deepest parts of the ocean and allowing life to exist in the abyssal depths. There's something deeply soothing about the ocean conveyor belt. The idea that water circulates through all the world's oceans, connecting the Arctic to the Antarctic, the Atlantic to the Pacific, in one slow, continuous flow. It reminds us of interconnectedness, that no part of the ocean is truly isolated, that what happens in one region eventually affects all others. The water molecules around you when you wade into the ocean have been on an incredible journey. They might have traveled from the Arctic to the tropics, from the surface to the abyssal depths and back. They've been part of clouds and rain, frozen into glaciers and melted again, absorbed by phytoplankton and released by bacteria, evaporated and condensed countless times. Each drop contains a history spanning continents and centuries. Beyond the grand global patterns, there are smaller-scale currents that create beautiful, complex flows. Upwelling zones, where deep water rises to the surface, are some of the most productive areas in the ocean. The cold, nutrient-rich water supports massive blooms of phytoplankton, which feed zooplankton, which feed small fish, which feed larger fish and marine mammals. These upwelling zones are like underwater oases, attracting diverse life from throughout the surrounding ocean. There are also eddy currents, circular flows that spin off from major currents. Some eddies are small, just a few kilometers across, while others can be hundreds of kilometers in diameter and persist for months or even years. Warm core eddies spin clockwise in the northern hemisphere and counterclockwise in the southern hemisphere, while cold core eddies spin the opposite way. These eddies transport water, heat, salt, and nutrients, creating complex patterns that influence local ecosystems and weather. The interaction between currents and underwater topography creates still more fascinating patterns. Water flowing over underwater mountains can create internal waves, waves that occur not at the water's surface but within the water column, at the boundary between layers of different densities. These internal waves can be enormous, with heights of tens or even hundreds of meters, yet they're completely invisible from the surface. They move slowly, sometimes just a few centimeters per second, creating gentle, rhythmic oscillations in the deep ocean that affect how heat, nutrients, and organisms are distributed. Tidal currents add another layer of movement to the ocean. Twice a day, in most places, the tide comes in and goes out, driven by the gravitational pull of the moon and sun. Where the tide flows through narrow channels or around islands, it can create strong tidal currents. In some locations, like the Bay of Fundy in Canada or the Pentland Firth in Scotland, tidal currents can reach several meters per second, creating dramatic whirlpools and standing waves. But in most places, tidal currents are gentle, a slow advance and retreat of water that brings nutrients, larvae, and sediments in and out of coastal ecosystems with each tidal cycle. All these currents, surface and deep, driven by wind and density, tidal and eddying, combine to create an ocean in constant, gentle motion. The water is never still, yet the motion is so gradual, so patient, that it speaks of timelessness rather than urgency. There's no rushing in the ocean conveyor belt, no hurry in the upwelling of deep water that began its journey 1,000 years ago. The currents remind us that movement doesn't have to be frantic to be purposeful, that the slowest flows can carry us the farthest. Tonight, imagine yourself drifting in the open ocean, far from shore. The water is calm, the sky is clear, and you're floating effortlessly, held up by the salt water's natural buoyancy. Beneath you, you can sense the currents, not as something turbulent or frightening, but as gentle rivers within the sea, flowing slowly, purposefully, on their ancient paths. You're not being pulled or dragged. You're being carried gently, peacefully, as a leaf might be carried by a quiet stream. There's no effort required on your part, no need to swim or struggle. The current knows where it's going. It's been traveling these routes for millions of years, following the gradual pull of temperature and salinity, the gentle push of wind, the rhythmic tug of the tides. Trust the current. Let it carry you. Feel how it supports you, how it moves you slowly through the warm water, how it connects you to all the far-flung corners of the world's oceans. You're part of the flow now, part of the great circulation that connects all seas. Let this current carry you down into the peaceful depths of sleep, knowing you're supported, knowing you're moving toward rest as surely as water moves through its timeless cycles. The peaceful depths, the twilight and midnight zones. As we descend deeper into the ocean, we enter realms that seem to exist outside of time, places where the pace of life slows to match the eternal darkness and crushing pressures. These are the twilight zone and midnight zone, and they teach us about adaptation, patience, and the existence of peace in environments that seem utterly hostile to life as we know it on the surface. The twilight zone, or mesopelagic zone, extends from about 200 meters to 1,000 meters below the surface. This is the realm of fading light. At the upper edge of the twilight zone, enough sunlight penetrates to create a dim, blue glow, but as you descend, the light fades until, at around 1,000 meters, even this faint glow disappears completely. Photosynthesis becomes impossible in the twilight zone. There simply isn't enough light for plants or algae to convert sunlight into energy. Yet life persists here, and in remarkable abundance. Some researchers estimate that the twilight zone contains more fish biomass than all the rest of the ocean combined. The creatures that live here have adapted to the dim light in fascinating ways. Many have large eyes to capture every available photon of light. Some have tubular eyes that point upward, allowing them to spot the silhouettes of prey against the faint glow from above. Others are almost entirely transparent, making them nearly invisible in the dim blue light. One of the most remarkable features of twilight zone life is the daily vertical migration that many species undertake. Every evening, as the sun sets, vast numbers of fish, squid, krill, and other animals migrate upward from the twilight zone toward the surface to feed in the productive surface waters under cover of darkness. Before dawn, they descend again to the safety of the deep, where larger predators can't follow. This migration involves hundreds of millions of tons of animals and is one of the largest movements of life on Earth, occurring every single day in oceans worldwide. Yet most people are completely unaware it's happening. The descent from twilight into midnight, the bathypelagic zone, which extends from 1,000 to 4,000 meters, brings us to a world of permanent darkness. No sunlight has penetrated to these depths for millions of years. The water pressure at 1,000 meters is about 100 times that at the surface. The weight of the entire water column above presses down with tremendous force. Yet the animals that live here are so well adapted that they experience this pressure as normal. Their bodies are filled with fluids that don't compress, so they don't feel crushed. If you could bring a deep-sea fish quickly to the surface, the rapid pressure change would harm it, but in its natural habitat, it moves through the pressure gradients with ease. The midnight zone is not lifeless. Rather, it's a place of slow-motion existence. Food is scarce here. Most of it comes from above in the form of marine snow, a constant, gentle rain of dead organisms, fecal pellets, and other organic particles drifting down from the surface waters. This marine snow settles slowly through the water column, and the animals of the deep sea have evolved to make the most of this limited resource. Metabolic rates in the deep sea are extremely slow. With less food available and colder temperatures, in most deep ocean waters, the temperature hovers just above freezing. There's less energy for rapid movement or growth. A deep-sea fish might go weeks between meals. When food arrives, it's an event to be taken advantage of. Many deep-sea fish have enormous mouths and expandable stomachs, allowing them to consume prey as large as or larger than themselves, then slowly digest it over an extended period. The darkness of the deep sea might seem oppressive, but the creatures that live there don't experience it as we would. Many deep-sea animals have lost their eyes entirely. In a world of permanent darkness, eyes are an unnecessary luxury. Others have evolved to create their own light through bioluminescence, which we discussed earlier. In the midnight zone, bioluminescence becomes the primary source of light, creating a world where living organisms are the stars, producing flashes, glows, and patterns of light that serve as communication, lures, and camouflage. There's something profoundly peaceful about the midnight zone once you adjust your perspective. This is a world without day or night in the conventional sense, without seasons, without the rapid changes that characterize life at the surface. The temperature is constant. The pressure is constant. The darkness is constant. Life here unfolds in slow motion, creatures drifting through the water with minimal movement, conserving energy, waiting patiently for the next meal to arrive on its slow descent from above. The deeper we go, past the midnight zone into the abyssal zone, 4,000 to 6,000 meters, and the hadal zone, 6,000 meters to the deepest trenches at nearly 11,000 meters, conditions become even more extreme. The pressure in the deepest parts of the ocean exceeds 1,000 times atmospheric pressure. The temperature is just a few degrees above freezing. Food becomes scarcer still, and yet, even in the Mariana Trench, the deepest point in any ocean, life exists. Small fish, amphipods, and other creatures make their homes in these ultimate depths, proving that life can adapt to almost any condition our planet offers. Recent research has revealed that the deep ocean, far from being a static, unchanging environment, actually experiences its own slow rhythms. Water masses move through the deep ocean at speeds measured in millimeters per second or less, yet this movement is enough to distribute nutrients, transport larvae, and connect deep-sea ecosystems across vast distances. Even the smallest deep-sea currents create habitats, as organisms orient themselves to face into the flow, maximizing their chances of intercepting food particles drifting by. The deep sea also hosts its own unique ecosystems built around hydrothermal vents and cold seeps. At hydrothermal vents, water heated by volcanic activity deep within the Earth's crust emerges from cracks in the seafloor, carrying minerals dissolved from the rocks. Bacteria capable of using the chemical energy in these minerals form the base of a food web that supports tube worms, clams, crabs, and fish, an entire ecosystem powered not by sunlight but by chemical energy from Earth's interior. These vents were discovered only in 1977, a reminder that the deep ocean still holds secrets and that there may be entire ecosystems we haven't yet discovered. Cold seeps, where methane and other hydrocarbon-rich fluids seep from the seafloor, host similar communities. The methane provides energy for specialized bacteria, which in turn support diverse animals adapted to these unusual conditions. Both vents and seeps create oases of life in the deep sea, proving that where there's energy, whether from sunlight, chemicals, or other sources, life will find a way to harness it. The deep sea asks us to reconsider our assumptions about what environments can support life, about the pace at which life must operate, about the necessity of light and warmth. It shows us that peace and stillness can exist even under crushing pressure and in absolute darkness, that slow doesn't mean dead, that patience and adaptation can open up even the most extreme environments to life. Tonight, as you prepare for sleep, imagine yourself descending slowly, safely, comfortably into the deep ocean. You're in a protected sphere of calm, perfectly pressurized, perfectly safe. As you descend, the light fades from bright blue to dim blue to violet to the faintest shimmer. Around you, you begin to see the lights of bioluminescent creatures. Tiny sparkles, soft glows, brief flashes. Each light is a life, a being going about its ancient business in the eternal dark. The descent is slow, peaceful, hypnotic. The pressure all around you is not threatening but comforting, like being wrapped in a blanket, held secure on all sides. You descend further, and the bioluminescent lights become your stars, scattered through the darkness like a galaxy. There's no sound here except the slow beating of your own heart. No rush, no urgency, no demands. Just the peaceful dark, the gentle lights, and the knowledge that even here, in the deepest, most remote part of the ocean, life continues its patient existence. Let yourself sink deeper still, down past the midnight zone, down toward the abyssal plains where the pressure of the ocean above is like a gentle hand pressing you down into the soft sediments of sleep. You're safe here. You're held here. Nothing can disturb you in these peaceful depths. Rest now in the deepest peace the ocean can offer. Tides and lunar connections, the rhythm of the moon. The tides are one of nature's most reliable rhythms, a daily rise and fall of the sea that has shaped coastlines, guided navigation, and influenced life for as long as oceans have existed. Understanding the tides connects us to the cosmos itself, to the gravitational dance between Earth, Moon, and Sun that creates one of the ocean's most fundamental patterns. The primary driver of tides is the Moon's gravitational pull on Earth. Gravity decreases with distance, so the side of Earth facing the Moon experiences slightly stronger gravitational pull than Earth's center, and Earth's center experiences slightly stronger pull than the side facing away from the Moon. This difference in gravitational force across Earth's diameter creates what's called a tidal force. On the side of Earth closest to the Moon, the ocean is pulled slightly toward the Moon, creating a bulge of water, a high tide. Simultaneously, on the opposite side of Earth, there's another bulge. This second bulge occurs because the water on that side experiences less gravitational pull from the Moon than Earth's center does. So the water effectively gets left behind as the solid Earth is pulled more strongly toward the Moon. The result is two bulges of water on opposite sides of Earth, both aligned with the Moon. As Earth rotates on its axis once every 24 hours, different parts of the planet's surface move through these bulges. When your location rotates into one of the bulges, you experience high tide. When you're in the regions between the bulges, you experience low tide. Because there are two bulges on opposite sides of Earth, most locations experience two high tides and two low tides each day, a pattern called semi-diurnal tides. The timing of the tides shifts each day because the Moon is also orbiting Earth. The Moon completes its orbit around Earth roughly every 29.5 days, which means it moves about 13 degrees in its orbit each day. Earth has to rotate a bit more than 360 degrees for a given location to line up with the Moon again. This extra rotation takes about 50 minutes, so each day, the tides occur about 50 minutes later than they did the day before. If high tide was at noon today, it will be around 12:50 tomorrow. The Sun also creates tidal forces on Earth, though they're weaker than the moon's tidal forces, about half as strong, because while the sun is much more massive than the moon, it's also much farther away, and gravitational force decreases rapidly with distance. When the sun, moon, and earth are aligned, which happens at full moon and new moon, the sun's tidal forces and the moon's tidal forces add together, creating especially high tides and especially low tides. These are called spring tides, though the name has nothing to do with the season. It comes from the idea that the water springs or rises notably high when the sun and moon are at right angles to each other relative to Earth, which happens at first quarter and third quarter moons. Their tidal forces partially cancel each other out, resulting in less extreme tides called neap tides. During neap tides, the difference between high and low tide is minimized. The cycle from spring tide to neap tide to spring tide again follows the lunar cycle, repeating every 14 to 15 days. The magnitude of tides varies dramatically depending on location. In the open ocean, the tidal range, the difference in height between high and low tide, is typically only about half a meter. But when tidal bulges move into confined areas like bays, estuaries, or channels, the water can be squeezed upward dramatically. The Bay of Fundy in Canada experiences the world's highest tides, with a range that can exceed 16 meters. Twice a day, enormous volumes of water flow into and out of the bay, creating powerful tidal currents and exposing vast mudflats at low tide. Coastal ecosystems have evolved to thrive in the intertidal zone, the area between high and low tide marks. This is one of the most dynamic environments on Earth, alternately submerged and exposed, yet it supports remarkable biodiversity. Barnacles cement themselves to rocks and close their shells tightly when the tide recedes, waiting patiently for the water's return. Sea stars cling to rocks, their tube feet creating suction that keeps them in place despite crashing waves. Mussels cluster together in dense beds. Sea anemones retract their tentacles and appear as nothing more than jelly-like bumps on rocks at low tide. But when the water returns, they bloom like flowers, tentacles extended to catch passing prey. The tides create a predictable rhythm that intertidal organisms use to regulate their activities. Many creatures feed when submerged and rest or seal themselves up when exposed. Others time their reproduction to tidal cycles. The grunion, a small fish native to California, spawns only on the highest spring tides, when the beach extends farthest up the shore. The fish ride the waves onto the beach, bury their eggs in the sand, and return to the sea. The eggs develop safely above the normal high tide line and hatch when the next spring tide, about 2 weeks later, washes them out of the sand and into the ocean. Tides have been crucial to human activities for millennia. Coastal peoples have used tides to guide fishing and gathering, knowing when the low tide will expose productive mudflats and tide pools. Ancient coastal structures, from Roman fish ponds to Hawaiian fish ponds, were designed to work with the tides, trapping fish when the tide came in and making them easy to harvest when the tide went out. Tidal mills, which used the movement of tidal water to turn wheels and grind grain, were in use in Europe and the Middle East for over 1,000 years. The predictability of tides made them useful for timekeeping. In many coastal cultures, the day was divided not just by the sun's movement but by the tides. People would speak of events happening at 2 tides past, or plan activities for the next high water. Even today, tide tables are essential for maritime navigation, telling sailors and fishermen exactly when the water will be high or low, when currents will be strongest, and when it will be safe to enter shallow harbors or cross dangerous bars. The moon's influence on Earth's tides is gradually changing Earth's rotation. The tidal bulges created by the moon's gravity exert a small but constant friction on Earth's rotation, very slowly slowing Earth's spin. This slowing is tiny. Earth's day lengthens by about 0.002 seconds per century, but over geological time, it adds up. Billions of years ago, days were significantly shorter than they are now, and a year contained many more days. Fossil corals provide evidence of this. The growth rings in ancient corals show they experienced more daily cycles per year than modern corals do. Simultaneously, as Earth's rotation slows, the moon is gradually moving away from Earth, receding at a rate of about 3.8 centimeters per year. This happens because of angular momentum conservation. As Earth's rotation slows, that rotational energy is transferred to the moon's orbit, causing it to spiral slowly outward. Hundreds of millions of years from now, the moon will be farther away, appearing smaller in the sky, and Earth's days will be longer. The tides will be weaker because the moon's gravitational influence decreases with distance. But for now, for all of human history and for millions of years before and millions to come, the moon will continue its reliable orbit, and the tides will continue their eternal rise and fall. There's something deeply comforting about the tides. Unlike so much in our unpredictable world, the tides are reliable. We can calculate exactly when high and low tide will occur years in advance. This reliability has been a source of metaphor and meaning across cultures. The tide always comes in, the tide always goes out. No matter what happens in our lives, the ocean keeps breathing, keeps cycling through its twice-daily rhythm. When we feel overwhelmed, it can help to remember that even our troubles are like tides. They rise, they crest, but they also recede. Tonight, imagine yourself sitting on a quiet beach as evening approaches. The tide is going out, and you watch as the waterline slowly, gradually retreats down the sand. The waves are gentle, just small swells that lap peacefully at the shore before sliding back. Each wave leaves a thin line of foam, and as the tide falls, these lines mark where the water has been, a record of the ocean's slow retreat. You're not impatient for the tide to change. You're content to sit and watch this ancient process unfold at its own patient pace. Behind you, the sun is setting. Above you, the moon is rising, nearly full, luminous against the darkening sky. You can sense, even if you can't see it, the invisible connection between that bright disk above and the moving water before you. The moon pulls, the ocean responds. It's been happening this way since there were moons and oceans, and it will continue long after you're gone. Let that continuity embrace you. Let the rhythm of the tides slow your breathing, calm your thoughts. Breathe in with the wave approaching. Breathe out as it retreats. The tide of your own wakefulness is going out now, slowly, gently, inevitably. Don't fight it. Let it ebb. Let it carry away the concerns of the day as it retreats. Soon, only sleep will remain, deep and peaceful as the low tide's still waters. The healing properties of seawater, the medicine of the sea. Throughout human history, people have attributed healing properties to the sea. Ancient Greek physicians prescribed seawater baths for various ailments. Roman upper classes would visit the coast specifically for the health benefits. In the 18th and 19th centuries, doctors in Europe and America routinely recommended seaside visits for patients suffering from everything from tuberculosis to depression. While some of these historical claims were overstated or misguided, modern science is discovering that there is real substance behind the idea that the sea can promote health and well-being. Seawater is a complex solution containing, at minimum, 80 different dissolved elements and compounds. The most abundant are sodium and chloride ions, which together make up about 85% of the dissolved material, giving seawater its characteristic salty taste and its average salinity of about 35 parts per thousand. But seawater also contains significant amounts of magnesium, sulfate, calcium, and potassium, plus trace amounts of virtually every naturally occurring element, from gold to uranium, though most in concentrations so low they're measured in parts per billion or trillion. This mineral cocktail has genuine effects on human health when absorbed through the skin or inhaled in sea spray. Magnesium, for instance, plays crucial roles in hundreds of biochemical reactions in the body, including muscle and nerve function, blood sugar control, and blood pressure regulation. When you immerse yourself in seawater, magnesium ions can be absorbed through the skin, potentially helping to relax muscles, reduce inflammation, and promote a sense of calm. The salt content of seawater itself has therapeutic properties. The osmotic pressure created by salt water can help draw toxins and excess fluid from the skin and underlying tissues. This is why salt water is effective for treating minor wounds and skin conditions. The salt creates an environment that's hostile to many bacteria, helping to keep wounds clean and promoting healing. Gargling with salt water for sore throats works on the same principle. The salt helps reduce swelling and kills bacteria. Swimming in seawater provides additional benefits beyond the minerals it contains. The buoyancy provided by salt water reduces stress on joints and muscles, making seawater swimming particularly beneficial for people with arthritis or other conditions that make weight-bearing exercise difficult. The resistance of water provides a gentle workout for muscles without the jarring impact of land-based exercise. The coolness of the water can reduce inflammation and help with post-exercise recovery. Perhaps most intriguing is the effect of negative ions. Breaking waves, particularly in surf zones, create enormous numbers of negative ions, oxygen atoms that have gained an electron and carry a negative electrical charge. These negative ions are abundant near the ocean and near waterfalls after thunderstorms, and in other places where water is in motion and breaking apart. Research has suggested that negative ions may increase serotonin levels, helping to alleviate depression, relieve stress, and boost daytime energy. The proposed mechanism is that negative ions are absorbed through the skin and via inhalation. Once in the bloodstream, they're thought to produce biochemical reactions that increase levels of serotonin, the mood-regulating neurotransmitter. While the research is still ongoing and not all studies have found significant effects, many people report feeling more alert, energized, and emotionally balanced after spending time near the ocean, and negative ions may play a role in this phenomenon. The air near the ocean is different in other ways too. Sea air contains trace amounts of iodine released when waves break and seawater evaporates. Iodine is essential for thyroid function, and while we typically get adequate iodine from diet, especially if we eat seafood or use iodized salt, breathing sea air provides another source. Historically, seaside sanatoriums were popular for treating tuberculosis and other respiratory ailments, partly because the sea air was believed to have medicinal properties. While antibiotics have made such treatments obsolete, There's still evidence that breathing sea air can benefit respiratory health, potentially due to its high humidity and the presence of salt particles which may help thin mucus and improve breathing. Beyond the direct physical effects of seawater and sea air, there are profound psychological benefits to spending time by the ocean. The sight and sound of the sea promote relaxation and reduce stress, as we discussed earlier. The vastness of the ocean can provide perspective on our problems, reminding us that we're part of something much larger than our individual concerns. The beach environment typically involves sunlight, which stimulates vitamin D production in the skin, though sun protection is important to prevent damage. Sunlight exposure also helps regulate circadian rhythms, improving sleep quality. Ocean swimming, or even wading in the shallows, often involves mindful presence. The sensation of water on skin, the sound of waves, the taste of salt, the sight of the horizon. These sensory experiences anchor us in the present moment, providing a natural form of meditation. This mindfulness can be profoundly restorative, offering relief from the constant mental chatter and future-oriented anxiety that characterize modern life. Walking on the beach provides its own unique benefits. The uneven surface of sand requires more muscle engagement than walking on pavement, providing a better workout for feet, legs, and core muscles. The repetitive sound of waves creates a natural white noise that can help clear the mind. The beach often provides an opportunity for social connection, gathering with family or friends in a relaxed setting, which is itself important for mental and emotional health. Some researchers have explored the concept of blue mind, a mildly meditative state characterized by calm, peacefulness, unity, and a sense of general happiness and satisfaction with life in the moment that people often experience when in or near water. Drifting into sleep. We've journeyed together tonight through the marvels of the sea, from its ancient origins billions of years ago to the daily rhythm of the tides, from the depths of the midnight zone to the sunlit shallows of coral reefs, from the haunting songs of whales to the gentle glow of bioluminescence. We've explored the healing properties of seawater, watched the peaceful dance of sea creatures, contemplated the vast sweep of time preserved in fossils, and witnessed the beautiful interaction of ocean and atmosphere. Through it all, certain themes have emerged. Patience. The sea has time, endless time, and it accomplishes its work not through force or haste, but through steady, persistent effort. Connection. Everything in the ocean is linked, from the smallest plankton to the largest whale, from the surface waters to the deepest trenches, from the ancient past to the present moment. Resilience. The ocean has endured through countless changes, adapting, evolving, but always persisting. Peace. Despite its power, despite its vastness, the ocean offers us calm, offers us rest, offers us a chance to let go of our burdens and simply be. The sea has so much to teach us, and perhaps its most important lesson is simply this: you can rest, you can let go, you don't have to hold on to everything so tightly. Just as the ocean holds up swimmers without effort, just as it carries currents across thousands of miles without strain, just as it has breathed in and out with the tides for 4 billion years without tiring, you too can trust in rhythms larger than yourself, can allow yourself to be supported, can give yourself permission to stop struggling and simply float. Tonight, as you close your eyes, know that the ocean continues its ancient work. Waves are rolling onto shores around the world. Whales are singing in the deep. Bioluminescent creatures are glowing in the darkness. Tides are rising and falling. Currents are flowing. Marine snow is drifting downward through the water column. The sea doesn't stop for your sleep, and that's comforting. It will be there when you wake, still rolling, still breathing, still patient and eternal. Before we drift off completely, if you've enjoyed this journey through the ocean's most relaxing facts, I'd be grateful if you'd subscribe to Deep Science Sleep and give this video a like. It helps others discover these calming explorations of science and lets me know you'd enjoy more content like this. Feel free to leave a comment about what ocean topic you'd like to explore next. There's so much more to discover in the vast blue world beneath the waves. Now let the sea hold you. Let its rhythms become your rhythms. Let its peace become your peace. Breathe with the waves in and out, in and out. Feel yourself sinking gently, like marine snow drifting down through layers of water, each layer darker and quieter than the last, until you reach the soft sediments of deep, restful sleep. No more words now, only the gentle sound of waves, the feeling of being supported by warm, salt water, the knowledge that you're safe, you're held, you're drifting peacefully towards sleep. The sea welcomes you. Rest now in its ancient, patient embrace. Good night and sleep well.